Guys, it's Peter again. Last time, we proved that our first design prototype in which air is blown into a Venturi tunnel is ineffective. In case you missed my first video, the link is in the description below. Despite the failure of the first design prototype, the Venturi tunnel can be derived into a double diffuser type, with the upper diffuser incorporated with a ducted fan so that it could avoid the turbulent air generated by the fan from going into the tunnel and casting a negative impact on the clean airflow in the tunnel. Here's a sample double diffuser type. As you can see, there's an inlet directly connected to the upper diffuser, which is used for accelerating the airflow in the duct using a ducted fan. But wait a minute, how should I design the inlet of the second diffuser? The idea is either building an extended inlet into the tunnel, or just building the second diffuser directly on top of the first diffuser. They both have decent advantages and obvious disadvantages. So how can I compare these two kinds of double diffuser ducts? The best and fastest way I can think of is computational fluid dynamics. I choose the flow simulation of SolidWorks because it takes less time to calculate the solution. What's more, because the scale of my model is small, exceedingly high precision is quite unnecessary for me.
Moments later.
The extended inlet type has an obvious low pressure area in the second diffuser, which demonstrates that the ducted fan is indeed accelerating airflow. However, the velocity cut plot and the flow trajectory reveal that there is a severe airflow obstruction on the lower surface of the second diffuser, which potentially causes dirty air in the second diffuser and loss of downforce. The method that the inlet is tangent to the upper surface seems to weaken the problem of the airflow obstruction, but the low pressure area is much smaller than the first type. Wait a minute. If the ducted fan has the ability to accelerate the airflow and suck the airflow from the tunnel, why don't we install the fan on the end of the first diffuser? The turbulent air generated by the fan isn't blown into the duct either. Welp, here we go again.
A few minutes later.
According to the cut plot, there is a high flow rate region in the diffuser, meaning that the fan is accelerating air inside of the tunnel. But there is hardly any pressure difference between the surrounding air and the flow in the tunnel. It probably is due to the high mass flow of the air in the tunnel. Therefore, narrowing the tunnel might reduce the mass flow rate. No obvious difference than the model showed a moment ago. What causes the problem? I believe it cannot be explained through the plot given by the flow simulation from SolidWorks, and I need to conduct real experiments on my model or utilize a more precise and professional CFD software, such as ANSYS Fluent. In other words, I need to invest more time. Well, this is the end of this video. If you guys like this, please hit the like button below. And thank you again for watching my channel, and I will continually posting my experiments on these downforce generating ducts. See you next time.